Okay, so number 10 here, 1.4, Foundations of Math 20. When it says prove, you can't use examples. Even if you use a billion examples, that's not a good enough proof. Okay, so you have to use an integer proof. You have to use an expression with a variable in there somehow. So when you square an odd integer, the result is odd. So remember what we learned, an even integer is 2n, and 2n plus 1 is our simplest kind of form for an odd integer. All right, so again, this is a form, 2 times some number plus 1. That's the form of an odd integer. So when you square an odd integer, that means that you're doing 2n plus 1 all squared. Now, please, 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 I've been teaching for decades and I see this every year. Do not do this. Okay, that's bad. Do not do this. Square this number and square this number. Don't do that. That's bad. You cannot apply the square to each term that is added or subtracted. You can't do that. You can only apply the square to factors, the things that are multiplied together. Okay, so don't do this kind of stuff. What you need to do is actually expand this out and see what the representation looks like. Okay, so 2n plus 1 all squared, if that's the same as 2n plus 1 times 2n plus 1. So you do your FOIL method there. That's 4n squared plus 2n plus 2n plus 1. That's 4n squared plus 4n plus 1. Okay, now you look at that and you're like, okay, how can we make this into this form? So the question is, can you do something to this expression here to sort of make it into this form?
Yeah.
Well, you have 2 times some number plus 1. Here's the plus 1 part. Okay, that's kind of nice. So how can I change this into 2 times some number? If I can write this expression with the factor of 2, then I should be good. I should have the form that I'm looking for. So because you can focus on these first 2 terms and you can take a 2 out of these first 2 terms, this is 2n squared plus 2n. Then you have plus 1. Okay, this is enough to show that this n right here is just some number. And some number can be expressed as an expression itself. So really, the form of this is 2 times some number plus 1. That's exactly the format for an odd number that we're looking for. Okay, so that'd be enough right there. You don't have to take 4 out. You don't have to take a greatest common factor out. If you took 4n out of here to have n plus 1 plus 1, then it's like, I don't know, does this really fit? It's close, but you see, all you're looking for is a 2 as a factor. So just take the 2 out. And then if you have some number plus another number and you square it, you times 2, that's still a number, right? So this expression is still in the format of 2 times some number. That's still some number. Okay, does that help answer that question? Yeah. All right. All right, so the big thing is with proving and number tricks like this one we did here at number 9 is using an expression with a variable in it and then doing operations to that expression so that you can show it in a different form. That's the number trick one. And then this is your proving one. It's the general form that we're trying to get down to. Okay? Any other questions about number 9 or 10? 10 specifically? No? We're good? All right.